Hello, Algebra 1 students. We are in Unit 6, Systems of Linear Equations and Inequalities. We are in Tier 1, Lesson 3, Solve by Elimination. Check off your booklet. Here we are in Lesson 3, Solve by Elimination. Sometimes when using substitution, we create really difficult fractions to work with. When this happens, there's another method called elimination that can be used. There are some requirements that are needed to use elimination. Requirement number 1, both linear functions must be in standard form. Requirement number 2, both linear functions must have matching coefficients for one variable that have opposite signs. Let's go do an example. So as we can see here, when dealing with systems and we're dealing with eliminations, one thing that I like to do is I like to label my equations. So I'm going to say this top one is equation 1 and this bottom one is equation 2. It's just a good habit to get into so you know kind of what's going on when we get into more difficult examples. But for this one, we can see that we have two equations, and in the first equation, equation 1, we have the x term that has a positive 3 coefficient. And then in equation 2, we have an x term that has negative 3 coefficient. And both of these equations are definitely in standard form, which is ax plus by equals c, to where 3 and negative 3 here are a values, negative 2 and positive 4 are b values, and negative 4 and 8 are our c values. So when you have both requirements met, all you do is then add the two equations together. So draw a line, and we're going to add equation 1 to equation 2. Well, 3x plus negative 3x gives us 0, and then negative 2y plus 4y gives us plus 2y, and then negative 4 plus 8 gives us positive 4. So now we just solve for y. So we have 2y equals 4, divide by 2 on both sides. Here's my balancing point. And I get y is equal to 2. I'm not done yet, because remember, when I'm solving systems, I'm looking for a point or an ordered pair, so I need something to go into my point. Well, I definitely have the 2 value for my y, right? Because it goes by x and then y. And to get my y value, I'm just going to take this 2 and plug it into one of the equations. I'm going to choose equation 1. So with equation 1, I'm going to have 3x minus 2 times 2, because I'm plugging that y value in the equation, equals negative 4. So I'm going to get 3x minus 4 equals negative 4. And then to get the 3x by itself, I have to add 4 to both sides. And I get 3x equals 0. And then I got to divide both sides by 3 to get x by itself. And I get x, well, 0 over any number is just 0. So my x value is just 0. I'm going to shrink some of this up for us. So now that I have my x and my y values, I can take my y value here of 2 and plug it into my solution, and I can take my x value here of 0 and plug it into my solution. So I'm in the form of x like y, like we talked about from the first lesson, and my solution to this linear system is 0, 2. Good luck on your practice sets.